Hi everyone and welcome to this new video in which I continue my Windows Privilege Escalation series. So in the previous video of the series we discussed about the user account control bypass, so the UAC bypass, and at the end of that video I showcase a specific UAC bypass that involved the usage of the configuration always install with elevated privileges. Now, in this video, we're going to talk about this configuration, the always install with elevated privilege configuration, and we're going to discuss why it represents a security issue and how it can be exploited to obtain code execution with higher privileges. Therefore, it can be used to do privilege escalation. Since this attack has to do with the creation of malicious MSI packages, at the end I will show a little extra on how to create a custom MSI. And as always, I will introduce the main ideas and concept, and then I will showcase everything in a practical way using a Windows virtual machine. So I hope the video is enjoyable, I hope you get something out of it. If you do, subscribe to the channel, share this video with like-minded people to help me grow here on YouTube, and that's it. Please enjoy the video. So let's start by discussing about this feature which is called always install with elevated privileges. Now it's a really simple feature, so it's not gonna take that much. Essentially the idea is that if you have this configuration in your system, then this is a policy setting that allows user to install software with elevated permissions even if they are not administrator, even if they do not have the higher integrity level. So the MIC level, even if it's not high, you can still install software. Now, what's the problem here? The problem is that during software installation, potentially arbitrary code can be executed. This means that software installation is a very critical moment within an operating system, because typically processes that deal with software installation, they need to have higher privileges, they need to have a high level of rights in the system in order to write into specific directories, in order to overwrite eventually environmental variables and things of the sort. So for a whole bunch of different reasons, when software is installed, the process handling that installation typically runs with higher privileges. Now this becomes a problem when we allow anyone to install new software even if they are not administrator. Because if anyone can install new software, even if not administrator, essentially it means that everyone can execute arbitrary code as a high privilege process. So in this case, the idea is pretty simple. We have a user which typically runs with a low privilege, so a user with low privilege. But then this user wants to install a software, and to install the software, you need higher privileges. And if any user is able to install any software without restriction, then users have a way essentially to escalate their privileges. How? By creating custom and malicious MSI packages, which is a Microsoft installer essentially. So that's the idea. So how do we check how we are configured with respect to this option? There are two ways. One is with the GUI and one is with the command line. I prefer the one with the command line, but I'm gonna show you both for completeness. So since we're talking about a policy, to actually see it, we have to open the program gpedit.msc. So we go into the virtual machine, we type this gpedit, essentially gpedit.msc, which is the program. So here I have to actually put my password, and this has to do with the UAC level actually that I showcased in the previous video, whatever. So in here, essentially, now I'm just gonna put it down because it's gonna be easier, just do notes like this. So there are actually two different configurations, both of which have to be enabled in order for this configuration to work. The first one we will see in the computer configuration section. So we go computer configuration, then administrative templates, then Windows components, then Windows installer at the end here, and finally always install with elevated privileges, and notice that it is enabled. In this case, let's actually disable it. So I'm gonna do edit and actually I'm gonna go disable. So edit disable, and then I'm gonna say okay, perfect. So now I have disabled it. So this is the first one. So computer configuration, templates. So here there's some typo, templates, Windows Components, Windows Installer. A similar configuration has been done also for the user configuration. So user configuration, administrative templates, Windows Components, Windows Installer, so here, and then always install with elevated privileges. Once again, let's just disable it to understand what it means to have it disabled. So this is the idea essentially. So we can just lower this and press OK, apply and OK. So now it's disabled on both. So this was the graphical way essentially with the local group policy editor with this tool. However, this is boring, so we want command line tools, that's much better. So here I have two CMD shells. This one runs with a medium mandatory level, so medium integrity level, while this other runs with a higher integrity level. So it means that in this one, in this white one here, we are privileged, we have access to more privileges. In this one, we are limited to a medium integrity level. So that's the idea. Now we can read the configuration with the function getItemProperty. We go into this specific registry key, HKLM, software policies Microsoft Windows installer, and we obtain, we read the item property with the name always install elevated. So we do this, we copy it here, and we get of course a 0 because we just disable it. We get a 0 for both the computer configuration and also for the user configuration, which has the same registry path, so software policies Microsoft Windows installer, but it starts with HKCU instead of HKLM. So we do the same thing and we should see another 0 essentially. So this is a safe configuration, meaning that it is disabled. For the configuration to work, both of these values have to be 1. Now what does it happen if they are 0 instead? Now to check what happens when we have this configuration at 0, so when it's not really activated, when this property is not activated, here I have a quick, simple MSI file called sample. I can just click on it and notice it says it asks me for the user account control permission. So to install the software, I need to pass a prompt which is gonna increase my integrity level. But if I don't pass this prompt, then I cannot install the software. So that's the basic idea. Of course, it's not gonna be able to install this package because it is malicious. But what's the idea here? The idea is that to actually install this software, I need to do a UAC bypass. So I need to do UAC bypass. What happens instead if we have this as level 1? So let's go to our commands here. I'm just gonna go to the notes. So to actually put it to 1, we can just use this set item property. Of course, we do need to have a privilege shell for doing this. We do not need like this one with the medium integrity level is not gonna work because we do not have enough privileges here. Clearly, access denied, permission denied. However, this one, it has enough privileges. So we're just gonna copy the instruction. So I suppose I need to copy better because it doesn't get it. Okay. I'm gonna set it for the local machine and also I'm gonna set it for the user account. So now they are both valued once and we can quickly check it by doing a get item of LM and a get item of CU. And look at this, they are both 1. Now notice what happens when I install this thing. Notice that now it does not ask me for UAC anymore. It simply bypasses that point and it starts to install it. Now, why is this malicious? Why is this bad? How can this be exploited? So let's say you have this configuration in your system, which means that both of these results, they get you 1. So both values are 1. How can we exploit it? Well, pretty simple. Look at this. 2 lines and we get higher privileges. The idea is that we're gonna generate a malicious MSI package, a software install package, a Microsoft software installer, which is the abbreviation of MSI. So MSI means Microsoft Software Installer. And then so we can generate it with MSF Venom. So pretty simple. Here we put the payload we want. So we want a reverse shell in TCP. This is our endpoint. So 192.168.122.1 port 777, so 4 sevens. And then here in the format we say MSI, Microsoft Software Installer. And we call it sample2 or sample whatever. Let's just call it sample for simplicity. This is we do in our Kali box. Then we transfer this file over the Windows machine, and within the Windows machine we execute it with a simple MSI exec, we put a bunch of flags to make this process quiet so that it does not pop up any other shell or whatever, like /quiet, /qn, /i, and then we put the name of the MSI package. And then we will have code execution, we will have a reverse shell on our target machine. So let's do it, it's really simple. Here I have another generated, but I can remove it because I don't need it. So let's do it, MSF Venom. So we're gonna generate this. And then essentially we go to our Windows box here. I'm gonna delete this two because we don't need it. And then, so let's go here in the CMD. So I'm in downloads. I'm gonna do netcat. So here I'm gonna put a listener to transfer the file. I'm gonna transfer this sample.msi which was generated with MSF Venom. And then here, essentially I'm gonna transfer it over to the machine. Notice I get a connection from the Windows virtual machine. So I can just stop it here. Look at this, now we have this installer. At this point, I just need to set up a listener to receive for the reverse shell connection. So the first one is for file transfer. The second one is gonna connect back to the reverse shell, which will allow me to execute arbitrary code as the admin account. So look at this. So in this shell, here I am UMI groups. Notice I am medium mandatory level. It means that I do not have full access to the machine. However, if I do this MSI exec like this, I can just copy it and I paste it here. Look at this. Look back, look down here. I have a shell. And if I do UMI groups on this shell, I get system mandatory level. So my level increase and now I have access to the entire machine. I have access to all of these privileges and in general I can do essentially what I want because this is the highest level I can get within this local machine. Why did this happen? Because the machine was poorly configured, it allows for this always install elevated property and it also allowed for a user to load an arbitrary MSI package. So combining these two things, I can just get simple access to a privilege integrity level, which in this case is system integrity level. And here another way to do it is much simpler. I put another listener and here I just do ./sample. It's gonna execute this and it's gonna give me the shell. However, in this case, it's gonna spawn these windows, which could be problematic if there is like someone viewing the desktop for this user. So in general, it's much quieter to just use the MSI exec. So this one, which does not spawn anything, but I still get remote code execution, I still get the reverse shell, which I then can use for whatever purposes I have in mind. So essentially, that's the idea, that's the core of the video. As I said, pretty simple because it's just a simple misconfiguration that you can have. If you are configured that in this case, the always install with elevated privileges is 1, then be careful on what kind of files you allow the users on your machine to install. If they can install MSI packages, then it's super simple. It's super simple because it's really simple to obtain then higher level privileges. Now to end this video, I actually want to show a little bit of an extra chapter, we could say, which is not strictly needed for exploitation. I mean, we already done here because this is it. This is all you need. It's a simple MSF Venom line. Of course, this payload does not evade antiviruses, EDR system and things of the sort. This is not the objective of this course for now. Maybe at the end I will briefly mention about those kind of things, but in general, that's the basic idea. Once you have this payload, then you can add on top obfuscation techniques, you can add on top loader techniques so that they are able to evade antivirus, EDR and system like that. So that's the idea. But now the idea is that, okay, how do we create a custom MSI that will execute a custom command? So not only a reverse shell, but any sort of custom command that we want. And to bring this example, I'm actually going to use Wix toolset and specifically the version 3.14.1, which allows exactly to create a custom MSI in what I would say is a pretty simple way. So not too complex, and we're going to be able to specify exactly how the build of this package has to be done, so that at the end of this process, we will have full control over what's going to happen when a user clicks on the MSI package. And so for this POC, for this proof of concept, I'm gonna use Wix version 3.14.1. Now this is important to mention. Use this version because for more recent version, which goes up to version 5, I actually not found documentation that was easy to follow. I mean, I did not want to spend too much time reading the documentation for the system. I just wanted something fast that I could use, that I could modify, and this was the earlier version that allowed me to do this essentially. So that's the idea. 3.14.1. You can just download it in the GitHub project in the releases with this particular version. So in this case, in this machine, I've already installed the program. And essentially here, I'm not sure where I think it's in Simple App. Yes, in the Simple App, here I have an example. And so specifically in this case, you just copy this GitHub, you go into the Windows machine because this is where you're gonna have to install it. Let's open Safari. Let's go into paste. And here, so I can just close this because we don't need it. And in this, you can just download the executable here, Wix 314exe. Then you click on it, you do the installation. It's pretty simple, nothing too crazy. And then you have it installed. Now, how can you use it? Well, the program that's going to install is going to install a program in this path. So in C program files x86 / Wix toolset version 3.14, we can go into this specific path, for example, with a different shell here. So I can just go into that path. And notice that here, okay, maybe I need to put quotes here because there are white spaces. And here I have a bunch of different programs, like a bunch of different executables. And out of all these executables, we're just gonna be interested in two, which will allow for the build of a simple MSI package. And these are the candle and light. So candle.exe and light.exe. To actually make it easy for you, here I also put the command to update your path, which is the environment you are working with essentially. So this is the path. So you can just open a shell. For example, let's say I open it here. I go and I say set path. Actually, okay, yeah, set path. And now I can do candle.exe. I think it's not actually like this, but it has to be on a command prompt. So it has to be on a command prompt. And then I can do candle.exe and I get access to the candle utility, or light.exe and I get access to the light utility. I can also do just candle and light, it's the same, it doesn't really change. So once we have access to both of these programs, we can use this sample XML to essentially introduce our malicious code. Because notice what happens in this sample. So it's a really simple file here, just a bunch of tags. And among these tags, we find here the CMD line tag, like this attribute CMD line on the property tag that says CMDexe whoami groups, and it just cuts it out in the desktop of QuickEmu into a file named test.txt. So what does it mean? What does this file essentially represent? Well, this file is used by the Wix toolset to understand what to do when installing the package. In this case, it's going to be a very, very simple installation process because we just want to introduce our malicious code, which is this line, and that's it. And then we want to stop. So that's the idea. We have this custom action, and in this install execute sequence, we say, okay, custom action stage 1, custom action stage 2. In this one, essentially, here it fails on this fail here. In this stage 1 instead, we are executing the command CMD line, which is this one. So essentially what we're going to do is just execute the command and then stop the execution. So that's really a simple idea. This is a simple script. What we can do here, for example, that I have it in this simple app directory. I have it here. I have a bunch of other files, which for now I don't need. So I can remove these files. I can remove the sample MSI. So the only thing that I have in this directory is this sample.wxs. I open it with like Notepad or something. Like Notepad is good. And notice this is exactly the XML file. It's just that right now I have a reverse shell in here, but it's the same thing, you know, I just whatever. Like for example, here I have a typical reverse shell that will start a reverse shell on this endpoint. Very, very simple, but the structure is the same as the one before. So let's say we have something like that. How can we use it? Well, just two simple commands. Candle, which will transform this file into a Wix object. So this is the first thing we do. We do candle of the file. So let's go into the simple app folder here. Simple app folder. Here I have this sample.wxs. Then I do candle here. It's gonna generate essentially a new file, which is this Wix obj, so Wix object. And then I do light. I can also remove the exe here, it doesn't really matter, whatever. Here the name is important, I have to say sample.wixobj. Here it's gonna give us some warnings, but we don't care, some errors, but we don't care, because at the end of the process, we still managed to obtain our sample.msi. And since our sample.msi was built with this malicious file that contains the reverse shell, now we can just set up a listener once again. So we're gonna set up a listener here, 7777. And then I'm gonna do the typical installation, so MSI exec quiet sample, so this one, and look down, here I have essentially a shell as, so I'm like whoami group, actually it's whoami, I would say groups, okay, no, not group but groups. And here I have system mandatory level, so system integrity, which is the highest. Notice that in this case, we actually spawn this window because this window is actually the process for netcat. So I obtained this reverse shell through netcat, so this window is kinda like not that good to have, but we can just modify the command to avoid having this window spawn. It doesn't really matter. I mean, in this file, where it is the, so let's open this sample, this one, open with Notepad. In this file, we can essentially put anything in this specific line. And when we install the program, so the full chain essentially is we obtain the MSI from this sample, and then when we do this MSI exec, here we have code execution. So when we're gonna install this package, the payload we put on this file is gonna get executed, which in this case is gonna give us the shell with system mandatory level. Why? Because in this system has been poorly configured with the always install with elevated privileges. So that's the chain. So this was a little bit of extra just to show how you can construct a custom MSI. I think it's a pretty cool thing. Let me know what you think. And essentially this is it for this video. Here I have a bunch of references on the Wix toolset and how to modify the Wix installer to run as admin. It's like an old forum. I just had some problems using it, and then I made it work by changing a flag essentially. And specifically it was this impersonate. So before it was impersonate yes, and it wouldn't work. Now I said impersonate no, and it does work. So essentially that's the idea, couple of references. So that's it for this video. I hope it was fun, I hope it was interesting, I hope you got something out of it. If you did, let me know, leave some feedback, subscribe to the channel, share this video with like-minded people to help me grow, and to the next video.